Okay, so the next one, the next truth table we're going to talk about is the disjunction. And remember, disjunctions convey the idea of or, and their symbol is the V. Now, okay, let's go back to the birthday party explanation. Let's say you're planning a birthday party and you tell your daughter, okay, you can invite anybody from your class, or you can invite any girl that lives in our neighborhood. It can be one or the other. So if she goes to her class, she's like, well, I can invite any girl or boy. So she picks some, you know. And then she goes to her neighborhood and she's like, oh, I'll pick anybody who lives in my neighborhood. Now, there might be one kid in her neighborhood who's actually in her class, but that doesn't matter because it's an or. She can do this or she can do that. She can pick one or the other. It doesn't matter. So it says a disjunction is false only when both statements are false. And you can see they show that at the bottom here. They highlighted it in pink. That is the only time a disjunction will be false. And I'm just going to slide back to the conjunction again. If you look at the conjunction, let me erase all this. You can see that the only time that it's true is when they're both true, because it's an and. They have to be both. Both has to be true in order for the whole thing to be true in a conjunction. But on a disjunction, as long as one of them is true, it'll be true. And the only time it's false is when they're both false. So on the false, she wants to invite this random kid, and the mother's like, well, is this person in your class? And she's like, no. Does this person live in our neighborhood? No. You know, maybe this person's from dance class or, you know, the softball team or something. I don't know. But the mom set out the stipulations. It could be this or it could be that. And the kid's trying to, you know, get around it. So that's a big no-no. So that's a false. So as long as, you know, the kid is from class or from the neighborhood, it'll be a true. Or, you know, maybe the kid that lives in the neighborhood is also in class. It's still true. So that's what a disjunction is. And that's what you need to remember. Okay, now this slide says, whoops, because of their similar structures, there are parallels that occur in logic and set theory. And remember that the set theory, we did that in chapter 2. And you can see that the set theory symbols were for intersection, union, complement, and subset. In logic, use another color here. In logic, the word and is kind of like the intersection. And you can see that the symbols here sort of, they're both upside down. One's an upside down V, the other one's an upside down U. And then for or and union, similar. And then for the word not, which is what we do in negation, that's kind of like the complement, because like, remember in the complement we had a circle, and so if this was circle A, then outside of A was the complement of A. So you were either in circle A or you were not. Get it? And then the if-then symbol, if everything in front of the arrow is also in the words after the then, that's kind of like doing a subset. So anyway, often if a result is true for set theory, then a similar result also holds for logic and vice versa. So, but you know, you probably have already blocked all the set theory stuff from your brain because you're like, I'm done with that chapter. Let's move on, April. So we're into truth tables now. Okay. All right, now here we go into compound statements. If the final column of a truth table contains all T's, if you have all T's, then the statement is always true, and they call that a tautology. So here's an example of this. This contestant will win or will not win. Okay, so for the will win part, let's see, need other colors here. They're going to let will win be the letter P, which is this column here. And so it's either true that they will win or it's false that they will win. And then you've got or will not win. And that's the negation of P. So if you negate P, if it was true, it's now false. And if it was false, it's now true. But they threw in the word or right here. And that is this symbol here. So you have to go back and look at each row, this row first, which you're going to compare the pink column with the orangey column. So if you're saying, okay, if I have a true or a false, true or false is true. And then you go to the next row and you're like, okay, I have a false or I have a true. False or true is also true. And so this is your last column. So I'll highlight, and I can't highlight it. This is your last column, and because you have a row of T's, you have a tautology. And that's what a tautology looks like. Now keep in mind, this is a very small one because I was only considering one statement, P. And when you have just one statement, it's either true or it's false. When we go into multiple statements, if we have P and a Q, two different statements, you're going to have 4 rows. And it's coming, but if you have a P, a Q, and an R, there'll be 8 rows. And we'll get to that.